Lesson 59 is all on experimental probability. Theoretical probability is found by analyzing a situation. If there's a lot of experimental probability, theoretical probability is a lot easier to figure out. We're going to focus on experimental probability. That's found statistically and is a ratio of the number of times an event occurs to the number of trials. So let's look at, maybe you're trying to find the probability of getting heads when you flip a coin. Well, there's two sides of a coin, heads and tails. So I've got here, I've got my number of trials, and you can see I have 1 trial, 2 trials, 3, all the way up to 4. In your book on page 401, there's a complete chart of all the way to 10 trials. Our outcome, you can see I flipped a coin, I got heads, then I got heads again the second time I flipped it, I got tails the third time I flipped my coin, and heads the fourth time I flipped my coin. To find the probability or the experimental probability, I take the probability that I want over the total number of trials. So let's fill this in as we go here. The probability for the first one, I wanted heads, so therefore I have 1 over 1. So therefore my probability is 1. On the second one, my trial, that's 2 trials. That'll go on the bottom. Notice the T comes from trials. Okay, that's the total number of trials. Now, so how many times have we gotten heads? Well, we've gotten heads twice out of 2 trials, so therefore our probability is still 1. Let's look at the third one. The third one, we did not get heads, we got tails. So therefore, we only got 2 of the outcomes we wanted out of a total of 3 trials, which when you divide 2/3, you get 2 divided by 3, which is 0.67. So that's our probability on the third one. And then the last one, well, we get heads again. So now we have 3 times out of the 4 trials we flipped our coin, which in decimal form is 0.75. Remember, to find that out, you would just take 3 divided by 4. The more times that you have experimental probabilities, so the more trials you have. So if I were, for example, to run this flipping of my coin out for 100 trials, we would see a pattern start to occur, and then theoretically, just because of how many times we flipped it, we know how many times we'll be able to get the outcome that we want. In this case, it is heads. Now, the more experimental probability there is, the easier it will be able to find theoretical probability. Experimental probability is used a lot in sports. An announcer might say he's made 80 out of 100 free throws. Well, that's kind of a lot to take in, so they might break it down or reduce this fraction and say that he's actually made 4 out of 5 free throws. These are 2 equivalent fractions. Also, you might hear an announcer say that he's made 80% of his free throws. Well, if he's made 80 out of 100 free throws, that's an 80%, because percent's out of 100. Let's look at example 1. A softball player has 21 hits in 60 at-bats. Express the probability the player will get a hit in her next at-bat as a decimal number with 3 decimal places. Usually at-bats in softball are expressed with 3 decimal places. That's why they're asking for that. Now, a softball player, remember, 21 hits, that's desired outcome over the total number of outcomes, which is 60 at-bats. So she's hit 21 out of her 60 times being at bat. This reduces down, if you reduce this fraction, it reduces down to 7/20. You can take 3 out of both of these numbers and get 7/20. Now, we want a decimal, so therefore we have to divide. 7 divided by 20. Well, 20 doesn't go into 7, so you can add your decimal point, because any whole number always has a decimal point right behind the whole number. So you can add zeros right behind the 7. Now, 20 goes into 70 3 times. 3 times 20 is 60. I subtract that off, I get 10 left over. I bring down my 0. 20 goes into 100 5 times. Bring my decimal point straight up, so therefore I have 0.35, but they want 3 decimal places, so therefore this lady's batting average is 0.350. In example 2, it says, a salesperson distributed free samples at the mall. 50 shoppers accepted the samples and 30 did not. What's the probability that a shopper will accept the salesperson's samples? We know that 50 accepted and 30 did not. If we add that together, we're going to find the total numbers of shoppers that happen to walk by. That's 80 shoppers. So this is our total number of trials. And remember from the beginning, total numbers of trials goes on the bottom part of our ratio. The top part of our ratio is always the part that we want. Well, we want how many will accept. Well, 50 out of the 80 that walked by accepted this. So 50 out of 80 shoppers accepted the samples. We reduce this down so it's easier to comprehend. When we do that, it becomes 5/8 of the shoppers will accept it. That's our probability that we're looking for. In example 3, it says, the commuter plane flight arrives on schedule 2/3 of the time on any given weekday. Heather wonders what the probability that it will arrive on schedule on a Tuesday, Wednesday, and Thursday in the same week. Part A says, how can experimental probability be found? Well, she could call and check arrival times over several weeks. This would be kind of hectic. She would always be calling the airport, checking on flight times, and it would take essentially forever. So Part B says, maybe this would help. How could the spinner be used to simulate the experiment? So just pretend that you're constantly spinning. It stops, you spin it again, it stops, you spin it again. Basically, you could spin it several times and find an experimental probability. So how could it? Spin it several times to get an experimental probability. For your practice to come to class with, you need to do the practice problems A, B, and C and bring it to class. A, B, and C can be found on page 403 in your book.